So we're moving on to the section 11E or 11.5, and this is example 5, which now changes what we've been doing from working in 2 dimensions to considering 3 dimensions, and Pythagoras' theorem can be used in a 3rd dimension as well. So what we're given is a cuboid. In this case it's called a box, and it's measuring 30 by 15 by 20 centimetres. We want to know, or the question asks, what is the longest piece of straight wire that can fit into here? Now, first of all, we're going to just look at the diagram and make a decision about where the straight wire is going to go. So we have our longest length is the 30 centimetres, and we have 20 centimetres here, and we have a height of 15 centimetres. So we could, I'm going to put a straight line on, we could quite conceivably just pop a piece of wire that went from A to C across there, but that's certainly not the longest distance. The longest distance actually goes from A all the way back to G. So it's sort of right across from one diagonal to the other. Of course, we could also fit it in different ways. We could go from D down to F over there, or we could go from H to B, or C down to E, but we'll consider it as being A to G. Now, in order to do that, we're actually going to need to form a different right-angled triangle. Now, I'm sure you can see that if we went across from A to F, then that would be the base of our triangle, and then F up to G would be the sort of the side that goes up to the back, and then this line that I'm going to draw in would be the distance, the length of the piece of wire. And what we end up with is this right-angled triangle in here, which we do have some of the information already, but we need to calculate some other information in order to make it work. So it's about being really organised, okay? So what I'm going to do is I'm going to draw each of these triangles that we need to use. So the first one goes from A across to B, B up to F, and then back across, and we're actually finding the hypotenuse here. So we've got A, B, F. Now what information do we have that we need to use? Well, firstly, A to B and B to F. We know both of those distances. A to B is 20 centimetres because it's the same as this length here from H across to G. So we've got A to B is 20 and B to F will be that longer length, which in our cuboid is 30 centimetres. So we're going to find this distance across the bottom from A to F, which runs across the bottom of our cuboid, and we're going to use Pythagoras' theorem initially to do that. So we've got 20 squared plus 30 squared, and that will equal AF squared. So AF squared is 20, I'm on my calculator, 20 squared plus 30 squared, that's 1,300. So AF is the square root of that, which is 36.0555 ... Okay, so I've got a few decimal points there, and that will come in useful in a little while. Now, we then need to consider the triangle that goes A to F to G. The reason I'm doing that, we've now worked out this length along the bottom, that's 36.0555 ... The length up the side, we know it's 15 centimetres, but that must be the same as this 15 centimetres over here. So we should now have the information we need to be able to work out AG. Let's just draw another right-angled triangle just to indicate the lengths that we've got and make sure we're getting everything in the right place. So we've got a right angle there. We have the base is 36.0555 ... The height is 15 centimetres, and this is A, G, and the bottom point is F. So we've now got a new right angled triangle, and I'm actually going to just move that down here just so that we've got a bit more room, and we can work out that longest piece of wire. So we have a squared plus b squared equals c squared, which I don't think I wrote last time, and I should have. Then a squared is 36.0555 squared plus 15 squared, and that will equal the length we're trying to find, the hypotenuse, which is ag squared. So ag squared is, and luckily I haven't pressed anything on my calculator, so I've still got the full length of AF, that 36.0555. So I'm going to square that, add 15 squared to it, and that is 1525. So therefore AG is the square root of that, which is 5 root 61, change 39.051 ... And I'm now just going to write that to a suitable degree of accuracy. Oh, I'm going to check the question. It doesn't give me what I should use for rounding, so I will say that that's 39.1 centimeters, and that's to 3 significant figures. And there we go. So Pythagoras works in 3 dimensions. However, it is highly likely you will need to work out the diagonal of a box or something similar before you will then have enough information to use Pythagoras' theorem in the way that we just have here. So good luck. It is about trying to visualize the problem. So if you're struggling, let me know. I should maybe be able to point you in the direction that will allow you to get the information you need to use Pythagoras. And crack on, exercise 11E.